All right, welcome to part 2. So now we're just going to do a few examples with these theorems that we just learned. So over here, we are trying to figure out where this intersection is, how we're going to solve for x over here. So our intersection is inside the circle, and notice B is not the center, okay? So this is where we have to use that formula. So whenever you have chords or secants that are intersecting inside the circle, this is where you're going to need to add the arcs. And some of you guys like forget, since we're like adding and subtracting and the formulas are so similar, you forget which one you have to use. So this is kind of what I try to remember. If they're intersecting inside the circle, then they kind of make like a plus sign over here. So it's like you see these two lines intersecting inside, they kind of make like a plus sign. So that's how you know that you should be adding these guys. So what is the formula that you're going to need? The angle is always going to equal 1/2 of the sum of the arcs. So arc AB plus arc CD. Then we just have to, oh my goodness. All right, hold please. Okay, all right, so what we're going to have to do is we're just going to have to fill in what we know. So what is the angle that we're solving for? That's x, so we're solving for that. And then 1/2 and the arcs are going to be AB, because those are the intercepted arcs for what x is. All right, so AB is 24 degrees, and then we have CD, which is 100 degrees. All right, so x is going to equal 1/2 of 124, which means x is going to just equal 62 degrees. All right, moving on over here. So this one is similar, but it's a little bit different. So this one, they are still intersecting inside the circle. So we are going to be adding. So we have the 75 degrees, so the intercepted arcs are going to be these guys. So we're still using kind of the same formula, or exactly the same formula that we did the last time. So the angle is going to equal 1/2 the arc of AB plus the arc of CD. Okay, but now we just have to fill stuff in. So this is where it gets different a little bit. So the angle that we're solving for over here is always the inner angle of the two arcs. So we know that this guy is 75. All right, and then we want 1/2 the two arcs. So we know that arc AB is 30 degrees over here, but now we're actually solving for arc CD, so we're adding x. All right, so how do we do this? First of all, you could distribute this 1/2, but then you have half of x. So what I would do is I would just get rid of that 1/2 first. So how do we undo 1/2? Well, 1/2 is the same thing as dividing by 2. So I'm going to multiply by 2 on both sides. So that way multiplying by this 2 cancels out that. So 2 times 75 is 150. No more 1/2, so I just have 30 plus x. And then I can subtract the 30. And I have 120 degrees equals x. And that's it. So if you can remember that, just multiplying by 2, this problem's not that hard either. So these are the problems where it's intersecting inside the circle. Now let's go on to these. So now for all of these are intersecting outside the circle. So when they intersect outside the circle over here, this is when you want to subtract. And it's always bigger minus smaller. So it's like you don't, like with this one, you're just adding the two arcs. It's not necessarily, it doesn't look like subtraction. Maybe it's just because I've seen it a few times, but for these, it's just like, okay, subtract them to get to the smaller thing. All right, but anyway, so color the intercepted arcs. So we always want to take, whoa, hold on. We always want to take the bigger arc over here, and we want to subtract the smaller arc over here. And then it says, write the appropriate formula. So the appropriate formula is just when we subtract. So we're solving for this angle, and the angle is always going to be outside the circle now, not inside. So that means we're going to take 1/2 the bigger arc, which is AB, and then we're going to subtract the smaller arc, which is CD in this case. Okay, and then it says substitute and solve. So what is the angle I'm actually solving for? That's what I'm solving for is x is 1/2. The bigger angle, my pink one, is 110. And then minus my smaller angle, which is just the green one, which is 49. And then over here, I'm just going to subtract these guys. So x is going to equal 1/2 times 61, which makes x equal 30.5 degrees. All right. So that's how you solve that one. Bigger arc minus smaller arc, cut it in half, gets you the angle. All right, the next one, it is also getting intersected outside. But now it says color the intercepted arc, so we're going to do that again. So my bigger arc is AB, my smaller arc is CB. And what do you notice about these arcs that I just colored in? Well, you should notice that they are half of a circle because this guy is going through your center. So CA is a diameter over here. So the measure, it doesn't give me, I'm supposed to be subtracting these two arcs to get to this angle over here, but it doesn't give me what the bigger arc is. But since I know that AC or CA is my diameter, I know that those have to be equal to 180 degrees. So can I solve for BA, arc BA? Absolutely. So all I have to do is do 180 minus 56, and that's going to give me 124 degrees. So this arc over here is 124 degrees. Now I can solve it like normal. I'm going to be using the exact same formula that I did before. I want the angle equals 1/2 of arc AB minus arc CB this time. Okay, and then I just have to plug stuff in. So I'm still solving for my angle. 1/2 AB, my bigger angle, is 124 degrees. CB, my small angle, is 56. 124 minus 56 is 68. And then just cut that in half. So this angle is going to be 34 degrees. Okay, one last one over here. And again, pause whenever you feel like I'm going too fast. Make sure you're getting it all written down. All right. So again, this guy is getting intersected outside the circle. Highlight your intercepted arc. So my major arc over here, my bigger arc goes ACB, and then my smaller arc is just AB. Okay, so again, over here, notice how the two arcs that I'm using, I highlighted the whole circle. So again, I'm solving for this x over here, but it didn't give me what this major arc ACB is. But can I figure that out? Yep. So this whole thing is 360 degrees because I highlighted the whole circle. And then I'm subtracting that 125 degrees from that minor arc. So that means my major arc is going to be 235 degrees. All right, and then write the appropriate formula again. So over here, we're solving for the angle 1/2 the major arc this time. So I have to have ACB because that's a major arc, and then minus the minor arc of AB, and then substitute. So we're still solving for the angle 1/2. My huge arc is 235 degrees. I'm subtracting the 125 degrees. So 235 minus 125 is 110. Cut that in half, and that arc is just 55 degrees. All right, so hopefully that makes sense because we're going to go on to a little bit more difficult problems with these. So very similar, but a little bit different. All right. So with these guys, same thing, but now you'll notice that we're given the angle and we're solving for one of the arcs. So for all of these, they're still, I'm just going to circle outside for all of these, they're still all going to be intersecting outside the arc. But now we're solving for arcs. So we're still going to highlight these guys. So I know that my bigger arc is 114. My smaller arc is just x, what we're solving for now. And write the appropriate formula. It's still the same formula, it's just now we're solving for something different. So the angle is going to equal 1/2 the bigger arc, which is AB, minus the smaller arc, which is CD, and then we're substituting it in. So this is where things change a little bit. So now this angle that we were solving for, we know that one. That angle is that 50 degrees up here. So we have 50 equals 1/2, and then we have 114 minus x over here. Whoops, sorry, moving it down. All right, so over here, what I would do is I would not distribute because I didn't have the 1/2 x, but you can if you really wanted to, but I'm just gonna multiply both sides by 2. So that way the 1/2 and the 2 cancel out over here. 2 times 50 is 100, and 100 equals 114 minus x. And notice how it's like a minus x. So when we subtract this 114, we should be expecting to get a negative number because we want to divide it by -1 eventually. So this is going to be -14 equals negative x. And then in order to turn them both positive, we just have to divide it by -1. So now I have positive 14 equals positive x. So that arc is going to just be a little 14 degrees. All right, that was the easiest out of the 3. So let's see what these guys have in store for us. Okay, so color the arcs. So again, my bigger arc is going to be AB. My smaller arc is CB. But again, another thing that you really have to notice with this one is CA is going through the center, so CA is a diameter. So whenever that happens, that's going to help us a lot because they're giving us that this is X. They don't give us what CB is, and then they give us the angle that we're solving for. The exterior angle is 36. So this one's a little bit more trickier. So let's think about this for a second. I need to know what CB is. So for this one, I know that these two have to equal 180 degrees, but I only know that this one is X. So how am I going to figure out what CB is? Well, CB has to be 180 degrees minus whatever this is. So we don't even get a nice number. We get an actual expression over here. CB is 180 minus X. All right, so again, write the formula. This should be the easy part because it hasn't really changed. So the angle is going to equal 1/2. The bigger arc is AB. The smaller arc is CB. All right, but now we have to substitute this stuff in. So this is where it gets kind of weird. All right, so we have the angle. So the angle is that 36 degrees over here. We know the 1/2 is a constant. Now we know that arc AB is just going to be X. That pink one is just going to be X. And then we said that arc CB is this 180 minus X. So we are subtracting 180 minus X. All right. So this is where it gets a little bit complicated, but you see, we still subtracted the arc. So this arc is X, and this arc has to be 180, whatever this minus whatever this arc is. So it's not that bad. All we have to do is distribute over here. So 36 equals 1/2, and then X minus 180, and then negative times a negative X is going to make it plus X. All right, then we can combine like terms. So 36 equals 1/2, and then we have 2x in here minus 180. All right, and then now you can multiply by 2 if you really want to, but both of these are even numbers now, so I'm just going to go ahead and distribute that 1/2. So 36 equals 1/2 of 2 is just 1x, 1/2 of 180 is 90. All right, now we finally have a nice easy problem. So add the 90, and 126 degrees is going to equal X. So that one was a little bit of a lot, but if you can just logic your way through that one, it shouldn't be terrible. So you just might have to practice that one or watch that one a couple of times, rewind and listen to it again. That's the nice thing about these videos. All right, the last one. So they are intersecting outside the circle again. I'm going to color the intercepted arcs. So my major arc over here goes all the way around. You should know what's kind of going on over here. My smaller arc is AB. Okay, so again, I don't know what my major arc over here is. I know that my minor arc is X and the angle that I'm solving for is 52. But so how do I figure out what is arc ACB over here? So if you'll notice, I highlighted the whole circle. So my major arc is going to be 360 minus whatever x is. And that makes sense, right? So you're taking 360, subtracting this arc out of it. Okay? Write the appropriate formula, same exact one that we've been using forever and ever and ever. So we are taking the major arc. We have to write 3 letters, A, C, B. We're subtracting the minor arc of A, B. Okay, now we're just going to plug stuff in. So we know that the angle over here that we're solving for is 52. Okay, we want 1/2. Now, we already said that the major arc is going to be 360 minus whatever x is. So we have 360 minus x, and then we are subtracting the smaller arc. So we're subtracting just x. So this one's a little bit nicer to where we don't have to distribute. We're just subtracting 2 x's. So over here, all we have to do now is combine like terms. So 52 equals 1/2, 360 minus 2x. And again, both of these guys are even, so I'm just going to go ahead and distribute this 1/2. So 52, half of 360 is 180. Half of 2x is just x. So now we're going to subtract the 180. And again, it should be negative because we have this negative x over here. So it's going to be negative 128 equals negative x. Divide by -1, and we get 128 degrees is what that minor arc is. All right, so again, I know those last 2 problems were a lot. You can always rewatch them. Make sure you know what's happening because I will give you a teeny quiz over this when we're all done reviewing. Okay, pop quiz. So if I were you, I would pause this and see how much you know, if you can figure these out. They're kind of little brain teasers, but you should be able to figure them out. So let's see, let's look at the first one. So measure of AB. So arc AB is this guy over here. So notice this is something that we did on the last one, 11.4. This is an inscribed angle. So we should know that our inscribed angles are always half of the arc. So if I'm given the angle, that means I have to multiply it by 2 to get the arc. So my arc is going to be 48 degrees for this one. And then the next one is figuring out what AC is. All right, so they give us that BC is 52. We know that AB is 48, and that would complete the whole circle. So all we have to do to solve for this one is 360 minus 152 minus 48, and that's going to give us what AC is. So if you subtract all of that, you should be getting 160 degrees. All right, this one, the measure of angle 1. So this is something that we dealt with this unit. We just did a bunch of problems over it. So we have this arc and we have that arc, and we just have to subtract them in half of it. So angle 1, or x, is going to equal 1/2 of 86 minus 30, which is going to be half of 56. Woo. Which is just going to be 28 degrees. All right, now this one you're going to have to use your brains a little bit more. So now it wants to know what the measure of EF is going to be. So we know that we have 86 here and 30 here, but the other thing that we know that's going to help us with this problem is these guys right here. It gives us congruent chords inside the circle. And again, this is from a couple of units ago. Whenever they give us congruent chords, that means these arcs are also going to be congruent. So these arcs are also going to be congruent. So if we know, notice how I highlighted the whole thing. So if we do 360 minus the pink arcs, so the 86 and the 30, that means we get 244 degrees. However, these 2 arcs are going to be congruent. There are 2 of them, so all we have to do is cut that in half to get a nice even 122 degrees for each of those arcs. All right, and that concludes section 11.5. Thanks for watching.